On this little measurement exercise. Yeah, this afternoon block of modules, these are the hands-on, and I think what we were looking at primarily in the morning was just the theoretical or the overview, conceptual things about manufacturing. We're actually doing some things that you apply, whether it be in the job screening process or in the manufacturing job itself. And the last module that we do, it's the last one that we have a PowerPoint on. Module 6 is actually the capstone project, and that's just basically going to be showing you what the finished project is and what the objectives are for that. But we're going to talk about quality. And one of the things that came out in that 2013 survey that we had conducted was that entry-level employees needed to have a greater understanding of at least statistical process control, continuous improvement, and so forth, which is all under the umbrella of quality. So what we've got here is just some terminology and some other practices under this umbrella for quality. If time allows, we've got a little quick exercise on that. One of the instruments that you commonly can see under the umbrella of quality, and go from there. Quality, this is one of these things that you know it when you see it, but how do you define it? Quality is essentially, it's when a product meets or exceeds the expectations of your customer. If they have not taken this class, when we're testing out students in the career centers, you get a lot of answers where I think they've got the essence of what we're talking about, but the thing that really captures it is if the product is meeting or exceeding the expectations of the customer. And how does it affect the bottom line? Why is it so important today? I mean, especially in today's global markets, quality is especially important. If you're not putting out a good product, there's lots of other places around the world that they can look to purchase such products. So it affects your bottom line, and it helps you retain customers. It helps you maintain customers, and it's something that a lot of companies are striving to keep as part of their overall practice. They incorporate it right down to the entry-level jobs. You see more and more companies, they display out in the front of their businesses that they are ISO certified, whether it's 9001 or whatever the classification. And you need that in order to have access to global markets. And so there's formal training in order to achieve and in maintaining that ISO certification. If you don't, you're in jeopardy of losing a lot of customers. Some components of quality. You got to be proactive. That's one of the important things, especially if you're ISO. It's a case of where you try to address the root cause of the problem as opposed to treating the symptom. And you got to be very proactive in order to do that. It involves getting input from everybody within the team, and this is where the teamwork that we keep preaching in this program, this is where it really comes to being. We always talk about being a team player and so forth. Well, this is probably the area where it's really needed the most. If you've got some people who are lax and they just put out a product which they don't care one way or another if it's meeting the expectations of the customer, then it's going to hurt your bottom line eventually. But it involves teamwork. You got to have constant training, and that's the other thing about companies that are big on quality and in the ISO certification. The training is ongoing. It's not one of those things where you take your program, you go to a 4-hour workshop, and then you're good for another year, another 2 years, or whatever. It's an ongoing thing, a daily thing almost. Some companies, they talk about it at the beginning of every week, or maybe even almost on a daily basis. It's also very important that you have a good communication system in order to achieve your quality goals. So you've got to have that flow of communication from the top down and the bottom up. And also, one of the important things about it, they try to eliminate the subjectivity, the opinions in achieving quality. I talked about statistical process control. Just as its name implies, you're using statistics. You're gathering data, and you're interpreting the data to achieve your objectives.
Sir, can you go back? I'm not trying to be.
Mm-hmm.
Can this be fixed? If something's wrong on this, can this be fixed easily? Is it on a PowerPoint?
Yes.
Okay, I just want to say your receiver spelled wrong. So apply before E, accept after C.
Oh, well, that one, that's actually something that I got from a file. That one I wouldn't, okay.
I didn't-
Good catch.
Yeah, well, clip art, right? That's a rule I learned.
Yeah.
Good job, Mike.
I kind of pride myself on being a good speller too, but
You're excellent. That's the first mistake of
good catch. And you're sitting right in front of it. It
Yeah.
about hits you in the eyes, doesn't it? Okay, yeah, I'll try to replace that. See if we can find a better. But to obtain quality, you know, number one, you got to know what you're striving for. You know, what are the standards? You know, are we looking at a defect rate of less than 1%? What are we looking at? So you got to know what your standards are. And again, this is data driven. The companies that really use the ISO programs, it's data driven. It's not something where it's one opinion and you're taking their judgment over somebody else's. You've got data to back you up. And you got to know the specifications, the properties of what you're making. You know, are these things supposed to break under so much pressure? Are these things supposed to melt under a certain temperature? You got to know just what you're dealing with. Again, creating charts, databases, and knowing your tolerances. Those are the things which go into obtaining quality. Determining customer needs. First off, what is a customer? You know, what we think about when we think of a customer. Anybody have a definition?
Who's buying the product?
That's one type of a customer. It could be an external customer, and when you think of that word, yeah, it's the person, it's the company that's buying your product. But actually, there's another type of customer, and it's an internal customer within your organization. You know, if you're part of a multi-processing company, you're taking product and you're passing it on to the next step, to the next step. Those people down the line from where you're producing are also customers. So that's one of the things that a good quality organization addresses too, is just how good is your product from operation to operation within your overall structure. One of the things we talked about, the short answer questions. We do a lot of emphasis on the quality on those short answer questions. So, you know, when determining customer needs, these things you need to make sure you know that things are delivered on time, it's of the highest quality, the cost is reasonable. It doesn't have to be the cheapest, but if the customer feels like they're getting a good value for the product, they are willing to pay more. And then being able to provide that service anytime, anywhere. Another facet in the area of quality, we touched on this a little earlier, prototype. Prototype, it could be a full-scale model of a product. It was created during the product design and development stage. They're tested before actual production begins in order to take the bugs out, so to speak. And they've got to be realistic and cost-effective, and they've got to be able to be produced, you know, on a repeatable basis. You know, just having a small scale that doesn't function at all, that's technically not a prototype. It's got to be a full-scale functioning model of the product that you want to eventually produce and market. Quality metal inspection. This can be conducted by the supplier before shipment, and it involves identifying materials and handling the non-conforming materials. It's just good, prudent measurement that the supplier can practice to make sure that things are in place before they are shipped out to the customer. Continuous improvement, I've referred to that a few times. That is one of the buzzwords in manufacturing and in other organizations. It's increasingly important, and it will continue to be increasingly important. It's ongoing, and it's accomplished in a lot of steps. First off, you build a problem-solving plan, and you set your priorities. You plan according to the severity of the problem. You don't want to waste a lot of time on the little minutia. You might have a machine that's cranking out a lot of different kinds of defective products, but you don't want to focus your attention on the onesies and twosies. You want to get right to the ones that are the most prevalent, you know, the top 4 or 5 that might make up 80% of your total defects. So it's a prioritization type of a system. And again, as I said before, rather than masking the symptom of the problem, you go for the root cause. That is better in the long run. You know, if you mask the symptom, That might fix the problem temporarily for a day, a week, a month, or whatever, but then it recurs. One of the things that you got to do in a good quality plan is address the root cause of the problem. And then you continue to measure and monitor afterwards to make sure that you are continuing to meet your customers' needs. Little trick question I ask students. Let's just say you're producing small products, little screws, or in this case, you're a nail production company. Do you inspect every one of those things when you're producing? More times than not, students say yes. You visually inspect every nail that you produce, every little screw. Now, some products are big enough that yes, it is practical and beneficial to inspect. If you're producing automobiles or something along that line, yes, inspect every one of them. But for something like this, you do sampling. Every so often you draw a sample, you randomly measure to make sure that they are meeting the specifications. And specifications, we also call them specs. It's a detailed description of the limits that are acceptable for a particular product. You've got a couple of examples right up there. If you've got any other kind of illustration that would help drive home the point, give a visual to the student of what specs are, you're more than welcome to incorporate them. And this can include anything from the size to its appearance, the color and so forth. And you can use specs in a number of different ways. You can use them on work orders, drawings, prototypes, simulations on the computer, and so forth. I've talked a little bit about tolerances. We were working with tolerances when we were using the calipers and the rulers. And tolerances, that's the amount of variation that's allowed in measurements and in quantities. And, just looking at the example here, the width tolerance for the box in this illustration that you're looking here is a plus or minus 0.005 of an inch. And the actual width is 4 and 6/1000 of an inch. Is that within tolerance? Given the tolerances, it's plus or minus 0.005 of an inch, but the actual width is 4 6/1000. Would that be within the tolerances? No, not if your tolerances are plus or minus 1,000. So good for students to understand the concept of tolerances and what is acceptable and what is not. I talked earlier, a couple of slides ago, when we say customer, we think of the traditional customer. We are the seller and you are delivering goods or service to a buyer. Yeah, that is a customer. But there's also an internal customer. Internal customers, they're within your organization. They're your colleagues. They might be members of your team. It might be other departments, other shifts. It might be between you and the production line and the maintenance department. It might be between the production department and the engineers, or the production department and management. Those are all customers. There may not be money exchanged, but in a technical sense, they are customers. And then, of course, we have an understanding of what an external customer is. Customer communication. Again, this is something that we ask the student to have a good understanding of. When you're communicating to the customer, you need to follow 4 basic principles. Number 1, assure that the order is understood. You meet the quality standards of the customer. You assure that the price is competitive. Again, it doesn't have to be the cheapest, but if the customer feels they're getting a good bargain for the price. And then assure that the customer is satisfied every time. You got to do the follow-up. It's not enough to just terminate the communication upon the sale of the product. It's ongoing. You follow up and you make sure that it did get delivered on time, the product is good, and everything is fine. How do we achieve the the quality guidelines? Again, we see all these things out in front of hospitals, factories, and other organizations indicating that they are ISO certified. Our department at Rhodes State College is ISO certified. And what that means is that we have an ongoing measurement of how we do things, how we follow up with customers, and we get checked on this internally on a monthly basis, and then we have an external auditor coming in annually, and they'll draw samples of our customer orders or projects, making sure that the documentation is thorough, informative, and done properly. And then they give us an assessment at the end. And if it's satisfactory, then we got our certification for another year. There might be such a thing that we did not meet specifications on some things. We have to go back and correct that and then resubmit to get our certification. More times than not, though, especially when you've got somebody who's pretty prevalent in quality, they'll keep us on top of things on that month-to-month basis. And if we're deviating, they'll pull us back in and get us back in line. But the ISO is the international organization which sets the standards. And, with the global market being what it is, you got to have something like that. Otherwise, you don't know if the standards of your product from the United States are the same as the products that are coming from Europe or Asia or wherever in the world. So to assure customers in international markets that they are getting a consistent product, they came up with this ISO standard, and everybody is up against the same types of standards if they're going to achieve and maintain their certification. Another practice, another system is called TQM, or that's Total Quality Management. What we find in a lot of modern quality tools is that they originated in Japan, or they got practiced in Japan, might be a better way of putting it. They got their start in the United States, but we then brought them to Japan after World War II. Japan was pretty well destroyed following the atomic bombs and the other attacks when Japan surrendered. So the United States, a lot of their leaders, business leaders, political leaders, military leaders went to Japan to rebuild their industry, their infrastructure, and they brought in these quality standards, and Japan took them and really ran with them. And then about 20, 30, 40 years later, as they became more prevalent in the export market, their products became increasingly more competitive, and in some cases maybe even exceeded United States standards. So essentially, the things that you hear about in the quality umbrella, the Kaizens and the 5 S's and things like that, they may have been formulated in the United States, but they were taken and then advanced or even perfected, if you will, in Japan. One of the levels of achievement that you can achieve is Six Sigma. It's kind of hard for me to get my head wrapped around this in some cases, but basically it's a system that uses measurements to focus on process improvement and eliminate any possibility of variations. Again, it's very big on statistical process control. You use statistics rather than opinions and subjectivity. It strives for perfection. If you have Six Sigma, a Six Sigma level of certification, you can't produce more than about 3.5 defects per million opportunities. And an opportunity, it could be a lot of different things. It could be pieces, it could be events, it could be different things. And that's why they use this general vague term, opportunities. But in order to have that Six Sigma level, you need to have no more than 3.4 defects per million opportunities. And Six Sigma opportunity is the total quantity of chances for the defect. Process Sigma can easily be calculated by using a Six Sigma calculator. We have an electronic version on this PowerPoint that you would be able to access. And you plug in the numbers properly and it would give you your Six Sigma factor. Another instrument is called quality assessment. It's a company-wide review. It doesn't just cover activities. It may compare one company to its competitors. It's just basically seeing where you stand in relation to other companies in your industry, against your competitors, and so forth. Okay, another question which could be coming up in the test, again, this is under the umbrella of quality. Why would you inspect incoming materials? Number one, you want to make sure it's the right material and the materials meet specifications. You have the right quantity and the material is received on time. Those are the main reasons why you inspect incoming materials. You just don't take the customer's word for granted and then you find out when it's too late that you don't have the right product or the product is defective. or something's wrong with it. So this is why you make a practice of inspecting incoming materials all the time. Now some more terminology you probably are more familiar with. We're going to talk about lean manufacturing briefly. Everybody has talked about it in some places. They implement it. And again, this is not something which is exclusively a manufacturing concept. About any organization which is operating with less waste, doing as much, if not more productivity with fewer employees, they're practicing lean. And lean, it eliminates all waste. And anything that's defined as waste, it's something that doesn't benefit the customer. And if you want to determine whether it's benefiting the customer or not, you ask some basic questions. Does it add value to your product? Does it make it more useful, attractive, or pleasing? And if not, you change the process. And that's the general concept of what lean is. I was talking earlier this morning about, companies that they have bins and bins of scrap metal, and days past they just threw it, took it to the landfill. Now they've got a market, a person actually buys the thing. I mean, that's one of the concepts of lean. Another, and this is one of these practices which developed in the United States, I should say perfected in Japan, just-in-time manufacturing. And as its name implies, rather than having big warehouses of inventory, I can remember working in an automotive plant where, they just warehoused indefinite quantities of the products that they were making, automotive exhaust systems. You don't do that anymore. You might end up throwing it out. Things change. They change the model, and all of a sudden the product that you had mass produced is no longer compatible. You make it just in time, you deliver it, and it gets received just in a nick of time. It works okay in a lot of cases, but if you should have inclement weather, which could affect the transportation of the products, then you can run into some bugs in the process and run into some problems. Just bringing something home locally. Remember the tsunami that they had in Japan a few years ago? There's a company over in Salina, CAT, Salina Aluminum Precision Technology. Most companies were humming along and getting out of the recession, and I was talking to one of their executives, and I just said, things continuing to go well for you? And he says, actually, we can rock pretty hard because that tsunami in Japan is affecting the flow of our goods on the international market. Japan got hit very, very hard. It affected, the disbursement of information, the logistics and everything, and consequently it affected things in Salina, Ohio because of a tsunami in Japan. So, just in time works well in most cases, but it is subject to some flaws and things that you don't have any control of, like Mother Nature. But this is the gentleman who invented it. He was a former vice president at Toyota, Taiichi Ono, I guess that's how you pronounce him. And that was implemented almost 60 years ago. Another concept, cellular manufacturing. That's where small numbers of workers are grouped together to produce a similar type of part or product, and they can be teamed together to form a complete process. But basically you group people up by category. As you see here in this illustration, you've got people that do lathing, then they pass on their work to people who are drilling, milling, inspecting, and so forth, all the way down to packaging and distribution. Agile manufacturing, as its name would imply, that's a system where you can roll with the changes. If there's a sudden need to change because of customer needs or new technology, an unexpected event, you're able to implement it into your organization. It could take different forms. It could mean retooling your operation or training your workers on the fly or giving them different responsibilities. It's being able to adapt to change with minimal disruption. Supply chain manufacturing, this is an illustration of just the different components of supply chain manufacturing. You're going from the raw materials, suppliers, to the manufacturers, delivering to the consumer, and distribution. And I referred to this several times, statistical process control. What this is statistical evaluation of data. determines whether something is within control, if it's acceptable, and there are several different ways in which they can achieve this kind of data. And here are some examples. Run charts and control charts. Now let's just say, again, go back to the scenario in the factory where you've been producing some defective parts and they take on several different categories. They could be blemishes, they could be nicks, they can be short, they can be too long, whatever. What you do is you assign a running period of time. It can't be choppy where you're just doing some inspecting for an hour and then you skip and try it again a few hours later. It has to be a continuous run of a period of time, and you mark down each of the different defects. You categorize them, and then you keep a count on each one of them. Again, you mark it down if it was discolored. You mark it down if it was nicked. You mark it down if the length wasn't acceptable, and so forth. And then what you do is you analyze that data, and you determine what do you want to address to get to the root cause of the problem. Something else, flow charts, we've seen these in just about everything. You know, it could be anything from how an office routes a phone call to just how something is manufactured. And, you know, they could take many different forms. Flow charts have some basic symbols. Flow charts, if you're using them properly, what you see are the basic symbols. There's 5 of them. The oval, the elongated circle, that shows the beginning of a process. You got the rectangle. Rectangle indicates there's instructions or actions. The diamond, that's a point in which a decision is made. So, you know, if you've got something, you're going from, let's say, you're talking to somebody in the front office, they direct you to the receptionist, and then you got a choice, and that's where the diamond comes in. Okay, do they send you to a supervisor? Do they send you to the front office? Anytime where you've got a decision made, that's where you put a diamond. Parallelogram, the next symbol below, that indicates input or output, and then the arrow shows the direction in which the process moves. And this is something that we incorporate in our basic pathway class. We have them make a simple flow chart. Actually, it doesn't have anything to do with manufacturing, but what we ask them to do is we have post-it notes, and we ask them to recall an experience with a full-service restaurant, not a takeout like a McDonald's or a Wendy's, but a full-service restaurant. And from the time that they walk into the door, are they seated, served, pay, go out? Just pretty much a basic, no incident type of an experience. And then we have them go back and say, okay, what if you go into that restaurant and they tell you it's a 45-minute wait? Okay, then you got to change that symbol to the diamond. Okay, you got to make a decision. Do we stick around, or do we just say thanks but no thanks, we'll go someplace else to eat? And then you can branch off from there. Okay, if we're going to stay, do we go to the bar and eat hors d'oeuvres while we're waiting to get seated? Or do we just take the little alarm that a lot of restaurants go to and we go to an adjacent store and wait for that to go off before it signals? You know, you could just use a lot of these symbols, and what you have is you start out with a very basic vertical organization from walking into the restaurant to paying the check and going out to something which gets very elaborate. And the students can really expand on that. They think a little bit, they recall from personal experiences, and then what you do to them, you say, okay, this is something that you may need to implement in your work experience. This might be something that applies to your job, and how do you interpret that flow chart if you should see one at an employer that you should be working for. A Pareto diagram, this is something else that we have in our exercise packet, and this is where we bring a lot of our math skills in. This is actually a two-faceted chart. What it does is it helps determine root causes of problems. It combines two things. Number one, a bar graph. With the bar graph, this gives you an illustration of what your most frequent flaws are. And then the line chart that you see running over the top, that gives you an illustration of showing where you cross that threshold of 80%. Let's just say we want to address the problems which make up 80% of our problems. That bar or the line chart gives you the illustration which shows you where you cross that 80% threshold, and then from there you know that we don't need to address all of these problems. As you see the line chart, you have parts are out of stock, that made up 49, and that's the other thing I didn't tell you. With a Pareto diagram, you put your most frequent flaws in descending order. So your most frequent is the first, the next, the next, the next, and then you figure what the running percentage is. This is where your calculating skills come in. If you had, let's just say, 123 total parts, you calculate what the percentage of 123.49 is. And we've got math exercises to help calculate that. 49 is what percent of 123? Well, that makes up, about, a little more than a third of your total flaws, which corresponds here with your percentage bar. And then you add your running percentage total, 35, that makes up another percentage, about 25% of your total flaws. And you add that, you get up to here, and again, you run your line chart until you cross that 80% threshold, which is right about here. And so from there, it tells you that, okay, if we're going to get to the root cause of our problems, we need to address things breaking on the road, rear alignments, front alignments, cleaning paint and wheels, and parts being out of stock. And these are small potatoes, so to speak. You don't need to put as much attention to them. But it gives them an illustration of addressing a root cause of a problem. And if they get an understanding of that, whether it be reading it or actually drawing a Pareto diagram, that helps them get ahead in the job market. And we've had some students who have taken the class. We had one that was working at AAP. He was on disability. He was injured. He was actually saying that, I was just asking, has anybody ever seen any of these types of things, such as a process chart or a Pareto diagram? He says, yeah, at AAP, we actually use them. I said, I have to read them to understand, if we're within our acceptable limits or not. So we are getting some feedback that industry is using some of these things. And again, it give your students an edge in the job market if they've had some experience in either reading or creating Pareto diagrams. We do have some exercises in your binder book on that. A fish skeleton diagram, this is sort of a brainstorming issue. What you've got, the thing is, you can see here, it looks like a fish skeleton. This is your main problem, and let me go back to my PowerPoint. When I go to the PowerPoint, you've got 5, maybe 6 main components that go into the cause and effect diagram, and they're often referred to as the 5 M's and an E. The 5 M's are manpower, method, machinery, measurement, material, and environment. Those would go off on the bones that feed off of the main spine. And then from there you brainwash. Okay, you've got material problems. What's wrong with the material? Well, you branch off from that. Material's dirty. It's not the right material. Your environment has problems. Okay, the environment in the form of varying temperatures. Or people, personnel, your manpower. Okay, we're having a problem with operators. They're not being trained properly. Again, this is basically a tool that companies use to brainstorm to address a root cause of a problem. 5S, this is a practice that's used in some quality organizations. As its name suggests, you've got 5 things that begin with the letter S. Good illustration here. First you sort, and then you put things in order. You shine or clean. You standardize it. In other words, you maintain that practice indefinitely. You don't change your methods. You standardize it, and then you sustain it. You continue this beyond the 5S experience. And then here's sort, setting, cleaning, standardization, sustain. Some organizations might even implement an additional 3 S's, and that would be safety, security, and satisfaction. But the 5 S's are the core of the 5S principles. Kaizen, that's a Japanese term that means good change. And as far as Kaizen is concerned, It refers to activities to improve things in all functions. This isn't something that does things piecemeal. It's a systematic principle. You address the system, and if you address the symptom, then the little things will take care of themselves. That's basically how Kaizen operates. We've offered Kaizen workshops here at Road State College for incumbent workers. Get a lot of interest in it. In fact, we're at the point now where companies are saying we need something that's even more advanced than what you're offering right now. But companies want to know how to systematically put a system, improve your system and maintain it. And Kaizen is a tool which a lot of companies often refer to achieving those principles. And then finally, standard operating procedure. You hear that term, you think that's a verb. Actually, standard operating procedure, it's a document. You often refer to it as SOP. It's a step-by-step document on how you carry out a process, and they're designed to make the workplace safer and more efficient. And the SOP has to be a written document so that it's standardized, it prevents errors, misinterpretations, and so forth. And here's an example of an SOP at an organization on how lathes should be properly operated. You can have an SOP for just about anything, but that's another instrument that companies use for standardization in the attempt to maintain high quality standards within their organization. And that is it as far as our quality. Have there been any questions? I mean, that's kind of the heavier stuff, but if you get them exposed to this kind of thing, and companies are saying that there's increased demand for at least an understanding of quality and statistical process control and continuous improvement. If they have some kind of an understanding, that gives them an edge in the job market. Any questions on what we went over? Finally, we have just a few minutes before we go across the hall and show you the integrated systems troubleshooting portion. The capstone project, as its name suggests, a capstone, this is where you incorporate a lot of the skills that were in this lesson. And the way we've done it, we put together Lego cars and run Hot Wheel cars down a track. You've got the exercises in your book, but basically you break up into teams of 3 to 4 people, and you've got a Lego kit. Each piece of the Lego kit has a price. And we assign a price for the labor in producing these cars at 25 cents a minute, so that comes out to about $6 or $15 an hour, which is right about where a lot of entry-level jobs are. But you put them on a clock, a stopwatch, and this team gets its heads together, and they put together the Lego car. And just for making things interesting, we get some extra kits and we mark it up with, correction fluid or whatever will show up on these things. And if by chance they should put one of those defective pieces in their Lego car, we tell them to restart the clock to go back and fix it. And of course, that adds to the cost of production and the total cost of the whole project. And the idea is to do something as efficiently as possible. You can get Lego kits like this for $5 to $10. They're very inexpensive. And the work basically is involved with assigning a price. You can put whatever price you want on each piece of these Lego cars, and you can set your labor costs to whatever you want. But what you would need to have is a sheet which what the cost should be, and knowing knowing at least how much that is. The rest of it changes from project to project. Some teams take more time to produce the cars than others. You might have some that put a defective car together. That takes more time. But once you get that standardized, again, it's a very inexpensive way to help bring together all the different skills. So this brings in their teamwork and their management and collaborative skills together. And then once they put the car together, we stopped using the Lego cars. They do not go down a ramp very well. These wheels don't spin worth a darn. They end up going sideways and tumbling over more than they do rolling on their wheels. We just get a Hot Wheels car and buy a Hot Wheels track. Again, you get a section track, Hot Wheels for about 80 cents. You buy a 5-pack of Hot Wheels cars for about $10. And we just run them down the track. And the worksheet what they do is they run down the track 10 times, and they use a tape measure and measure the exact measurement to the 16th of an inch or whatever the specifications are. You know, if your tape measure only measures up to the 16th of an inch, then go with that. If it's more precise than that, you can go with that. But they measure it 10 times, have the students take turns measuring it so they know how to read a tape measure, write them down. They've got 10 lines, and then what they do is convert the inches and fractions to decimals, and they write down what the longest run, the shortest run, and what the average run is. And then do an assessment afterwards. We've got worksheets in that section in the module 6. You can get as elaborate on this as possible. If time allows, you can get very, very elaborate on, assessing just what was accomplished, how you can do things better, and get them to really think about the manufacturing process. Any questions? We threw a lot at you.